Good evening, everyone. A warm welcome to each and every one of you joining us for the inaugural workshop of the Future Innovators Challenge 2025, proudly organized by the IEEE Student Branch in collaboration with the IEEE Industrial Electronics Society Student Branch Chapter of the University of Moratuwa. Today's session is all about the journey of product design and development, where you'll gain valuable insights into product design life cycle and its application in real-world scenarios. To officially commence the program, now I invite the Vice Chairman of IEEE Student Branch of the University of Moratuwa, Mr. Nivishka Mansanayaka, to deliver the welcome speech.
Hello. Good evening, everyone. Hope you guys are having a great day and excited for today's session. It is indeed a significant and exciting moment as we come together for the launch of the very first workshop of the Future Innovators Challenge 2025. And as the Vice Chairman of the IEEE Student Branch of University of Moratuwa, it gives me a great pleasure to welcome all of you to this special session of FInnC 25, which is organized by both IEEE Student Branch and IEEE Industrial Electronics Society Student Branch Chapter of University of Moratuwa. And first and foremost, I would like to extend a warm welcome to our guest speaker this evening, Mr. Ranjan Kulathunga, Senior Tech Lead at the Embedded Systems Department of Zone 24/7. And it is truly an honor to have you with us today. Your presence and willingness to share the expertise with our participants is deeply appreciated. I would also like to warmly welcome all of the participants who have joined us today. Actually, you are the core of the FInnC 2025, and we are really excited to see the ideas and the energy you bring into this journey. And especially, I wish to take a moment to appreciate and welcome the executive committee and organizing committee members from both IEEE Student Branch and IES Chapter who made today's session a reality. To share a few words about this initiative FInnC 25, Future Innovators Challenge, which is in its second iteration now. It is an initiative designed to inspire passionate and forward-thinking undergraduates to go beyond the classroom, what they learn, and face real-world problems with creative and practical solutions. So we believe that while technical knowledge is essential, the ability to apply that knowledge into something meaningful is what is defined by innovation. So, and that is the gap we aim to address through this challenge. Also, although it is named as a challenge, it is not just a competition. It is a platform for learning and growth. That's why we are organizing this series of workshops. And our aim is to support our participants in becoming practical thinkers who are equipped to take the challenges tomorrow and eventually become future innovators. And today will be the beginning of that journey, the very first milestone in a series of engaging and insightful sessions. We hope that all of you will take full advantage of this and use this opportunity to broaden your perspectives. And once again, thank you all for being here today. And I'm concluding my remarks with the hope of experiencing this interesting session with you. And let's move forward with today's session. Thank you.
Thank you very much, Mr. Nivishka. Your leadership and dedication are truly inspiring to all of us. Now, let's move on to the most awaited part of today's session. As we welcome our special guest speaker of the day, Mr. Ranjan Kulathunga, Senior Tech Lead at Zone 24/7. With over 14 years of experience in the industry, he's a specialist in embedded systems, mechanical and electronic design, and programming, a well rounded expert in tech innovation. What's even more inspiring is his passion for helping young inventors and students. Since 20 his program at American Spaces on learning in STEAM field. So, without further ado, let's warmly welcome Mr. Ranjan Kulathunga to take the virtual stage and share his insights with us.
All right. Good evening, all. So I think I'm audible for all of you. So is it Udan?
Yes, sir, we can hear you.
All right. So shall I share my screen as well?
Sure, sir.
Okay. Right. All good, right? Right. So okay. So actually, good evening again. So today, actually, I'm going to talk about the cycles of the product designing. So with my experience with you, right? So I think all of you are from university, I mean undergraduate students. So then I would like to give some feedback from you first, because everyone have dreams, right? So I would like to know about your dreams as well, since this session, but to be some interactive way. So could you please type your fashion, I mean, future ambition in the chat box, if it is okay? So then I can get some idea about your future ambitions and everything in this chat box, right? So just type the future ambition, that will be helpful for me, right? Okay, because when we are in the childhood, actually, so we really love to do some innovations, like when you get some stuff like electronic circuits and everything. See, we always try to make some thing, right? Because of that fashion, actually, now it's that hobby become a job role nowadays. So always think about your future dreams. So that's why I just ask from you about future dreams. If you can type in the chat box, just type your future ambition. That will be helpful for the sessions as well. Right? Okay, so right. So next thing is, so one day you will get the degree, right? So nowadays, since we are in the AI era, so a lot of technology coming, and maybe even you have a degree, it's really difficult to find some kind of a job in the job market as well, right? So that is why. So in my session, actually, I added some points to brush up your skill sets to go for a industry. I mean, industry readiness guide, right? So so after you get the degree, maybe you have a couple of options, right? So one thing is immediately you can join for the academic. Second thing is you can join for the industry, maybe government or private. So what is the third thing? Actually, you can start your own thing, right? To be an entrepreneur, or you can do some business thing, right? But to do all these things, you need to have a passion, right? So nowadays, if you think about the job market in the market in the field, so a lot of jobs can be replaceable, right? So because of the AIs and technology coming to the field, so then most of jobs are replaceable. But now some jobs are the demand getting high, right? Think about next 5-10 years and think what kind of a skill set you need and what kind of knowledge you need to survive in the future, right? So otherwise, I'm pretty sure you will be failed, right? So as engineers, always think about the how you can solve the problems in the industry. So then you can your job role cannot replace, right? So then not only the subject matters, you need to have some skill sets, special skill sets in the future, right? So while this session, so some points I can discuss with you and think seriously, right? So it's really even nowadays it's really difficult to predict the future with latest technology, because a lot of jobs can be replaceable, right? So try to be a person which cannot replace in the industry, right? So with that, we can continue the session. So today I'm going to discuss some experience from my life actually about this product designing related stuff, right? From the concept to the manufacturing level. So we can discuss about the steps, right? Because most of the time during the university period, you are making some prototypes, right? So but to make it as a product, it's a difficult story and the journey, right? So we at least we have to have some idea. Even when you do some small project, try to follow these steps that will be helpful for you even when you're going for the industry, right? So you are now going to explain, you mean around 1 hour with me. So then I'm pretty sure you will gain something from this session, right? By the way, as they explain about me, I have some different hats. Basically, I'm working in Zone 24/7 as a senior tech lead. So apart from that, I have some different roles as well. Also, I have some patents as well. So I will explain about this IP, getting how to get the IPs in the product design later, right? So because that will be really important to secure your idea, right? So in the industry, when you go for industry, sometimes there can be a hardware projects. Since most of you are from electronic backgrounds, sometimes you have to design something from the scratch level. I mean, from the beginning to the product design level. Maybe you have to do some service and maintain things. It's depend on your company that you are going in the future. But sometimes you will get chance to do some product from the scratch to the manufacturing level. Sometimes you have to do some only idea level, right? But it's depend, right? Anyway, so in this product journey, product design journey, sometimes when you design something for the international market, so we have to think a lot, right? So to get the certificates and everything. So through this session, we can discuss, right? Actually, as a product designer, you need to have some idea about mechanical, electronic stuff and documentation and all over ideas, right? All skill sets you need to have to make some product, right? So actually my expertise mechanical designs and PCB designs. So I have done a lot of projects, more than 250 projects I have done in the field. So then I have experience. So we can discuss about those things soon, right? All right. So now let's start from the beginning. Sometimes even now you have to do some project, right? So in the industry, one day you have to do a project, maybe that idea from your side, or maybe the project idea given by the client, right? Two ways. One, you can think a project idea, or maybe client will give a project, right? So starting from that point to end mass manufacturing level, we have some steps, right? So in the industry, there are two ways to do the project: waterfall and agile methods, right? So waterfall method is straightforward method, but high risk sometimes, because I'll explain the reason later. So if you divide into the small task. It is called agile method. So we have a low risk, right? So we can test some milestones, right? So it will not go into the next level until we finished and fine tune that point, right? But overall, this is the way how we can do the project. So normally when we get the client requirement, it is very important, right? So actually, because when we deal with the clients, some clients are maybe too technical. Some don't have a technical knowledge, right? But we have to deal somehow, right? So our task is ask a lot of questions and do some conceptual designs, and then we can discuss up to some extent, and from that we can do the projects, right? After that, if it is a freeze, so then we have to find some information, right? So competitive products in the market. Even now when you are do a project, so then not only your project, you have to find about the other products in the market, and then you can get some idea what features they have, what is the uniqueness of your project, and what technologies they used, kind of that, right? So then that will be really important to get some idea about the competitive product, right? So even that competitive product chart, you should add into the pitch deck at the end, right? When you present your product idea. I'll share later. After that, so you have to design some conceptual design, maybe from the scratch. I mean, using pencil and paper, it's okay. If you have a 3D design tool, use SolidWorks or whatever tool to make some conceptual design. That is also important before start the project in real, right? I mean, when you do project, don't start with the whatever tool like Altium or SolidWorks. I mean, do not start the project. First of all, you have to do some conceptual design, right? So then you can start the idea, right? So after that, we can start the schematic design, layout design, right? And it is called ECAD, electronic CAD computer design. Also, we have to synchronize with the mechanical designs, right? So maybe you can use tool like SolidWorks or whatever 3D design tools, right? And also we have to discuss about the prototyping, and once you do the things, documentation and backup and testing. So after that, you have to do some patent, right? So likewise, to go to the mass manufacturing, there are a lot of stages, right? So we can start from the beginning. So now when you have a idea, right? So if it is a teamwork, first thing is take a paper and the pencil and write down all ideas. Maybe still you are not finalize your project idea, but writing things on the paper will be really effective, right? So sharing things, sharing knowledge. So this is called mind mapping. So when we are doing the brainstorm level, this is very, really important, right? So then people can add their ideas from the scratch level. You guys can discuss, right? So in the teamwork, this is, if it is a team project, this is really useful and very practical, right? Practical way to share your ideas into one paper. And while discussing, you can freeze one idea by doing brainstorm, right? So this is the way when you discuss, first thing is called brainstorming. While brainstorming, lot of ideas came to your mind, but respect others. I mean, every idea is really valuable. So then by discussing, select one topic and you can start the further, right? So then define the project idea and start design on that idea later, right? So likewise, you can start designing and you can do testing, then launch, right? So likewise, it's a high level idea of the product design cycle. Also, when you select the team, imagine if there is a 5 people, all are engineers, but same skill set, it is not effective, right? At least even in your team, let's say if it is a agriculture-based project, sometimes there should be a the farmer in your project, right? Not all engineers, they don't know about the real problem in the society, right? So those are called pain points, right? So when you do the projects, first of all, we have to identify the pain points, right? So what is the real problem in the society or industry? Identify a problem. It's a really difficult thing, and you should go to the field, right? Even recently, actually, I went to the Prevailing hospital, right? So this is really real story, and I just asked from them. I just grouped the doctors and the nurses, and I just asked from them, think about the hospital scenario, and then I gave a paper and for the group and asked them to write down the problems in the hospital, right? So actually there are a lot of problems came up, right? Starting from registration, and they have a lot of issues, like some people forget to bring the ID cards and everything. Even when you go to the registration, they should measure the height and the weight and all these things separately, right? So I just gave an idea why you cannot design a system uh, to get some height and measure all these things and put into the cloud, right? So even you can get some biometrics, but it is not practical because it's really difficult to get the biometrics if it is a public thing like a hospital, right? So there are some security issues as well. Taking pictures also not practical. So likewise, there are some limitation as well, but we can solve those problems up to some extent, right? So some problems are like in the hospital, there are a lot of food wastage, right? So people like to eat a lot of food, but if it is a diabetic patient, they cannot uh, get a lot of foods, right? So if you have a camera or kind of thing, you can analyze with the patient profile what kind of foods good for them and do some analytical thing, and they can predict or whatever thing in the screen to showcase, remove these things and balance your diet, right? So likewise, there are a lot of problems in the society. Likewise, actually in this competition also, the challenge, there are a lot of domains. So if you think about those domains, actually you have to go to the fields, right? You can go to the field, then ask about the real people about the pain points, what kind of problems you have. Don't think about the technology too much, right? So to solve the problem, you can find about the what technology you can use. But when as engineers, if if you want to really solve the problem, go to the field and find about real pain points and real scenarios, and then you have to think about the technologies, what kind of technologies you have to use, and it should be practical, right? So it should be affordable price, and even sometimes nowadays people are making a lot of solution for the elephant in the forest, so they design some protective method for them, but most are not practical, right? So likewise, we have to think about the practical scenarios as well when you design product, right? Actually in this challenge they gave this type of real domains. So actually when I go through this, you can do a very interesting project, not like a common thing, but think about real pain point in the society. Then you should go to the society for example, for a fitness and well-being sector. Maybe you can go to the gym, right? And you can ask about the gym manager what kind of problem you have. So and then they will give a problem list. Then you can think about the solutions as engineers. You have a solution and the technology. They have a problem, right? So if we merge these together, industry and the academic, so then we can come up with a real good product, right? And power and energy sector, maybe you can go to the Moratuwa, right? So then you can ask about a lot of, they have a lot of problems, and you can do some innovation for that, right? So likewise, go to the field and find about the real pain points. Those are called pain points, remember, right? So then when you make a solution, it's like a medicine, right? So you don't want to do a lot of marketing. if it is a perfectly fit for that problem, they will definitely purchase or get your idea, right? Okay, so as I mentioned, getting client requirement is really important, right? So actually in industry, we can say if you identify client requirement, 50% is done, right? Actually, that is true because when you when you discuss with the client, if you get in the wrong way, sometimes you can complete up to 90% of the project without getting the real requirement. But at the end, when you deliver the things to the client, so they can say, this is not what I expected, right? So then you have to come back, right? Again, you have to do the same thing and say, not the same thing. Again, you have to do a different way to solve their problem, right? It's a waste of your time and the money and everything, right? So that is why first ask a lot of questions from the client and even design a conceptual design. It will solve a lot of issues, right? So actually, when you generate nowadays, you have AI tools and everything. When you type a correct script, they will generate real images even, right? So the beauty of the technology, and you can use those technology to get real client idea, right? So then you can ask about the client, is that you expected, right? So if it is not, you can fine tune without starting anything. Maybe using pencil and paper, you can start, right? Think about that. So when you do the project, first of all, we do something like this, right? So normally when you design something, we can design a couple of different design. So then we can ask from the client, this is the way, this is the way. We can put some number 1, 2, 3 or ABC. So then we can ask from the client. So then they will select, this is what I expected, and then starting from that idea, we can do a detailed design, right? So based on the conceptual design, right? So it will change whole image, I mean, of the client about your skills, right? So actually, it's unexpected thing maybe for the client, right? So then maybe if it is client project, definitely you will get the project, right? So if you can do the rendering and sometimes you can provide the dimensions, right? And also when you provide this type of conceptual design, remember to add some scaling items like when you think about this one, you can scale it up, right? So you know the human scale. So then you can guess the size of this device, right? So likewise, maybe point, right? So kind of a thing to get some idea about the size, right? So otherwise, you don't know the real size of this device, right? So think about that as well when you deliver the things to the client. Okay. And also, most of the time, even for this project also, you will end up with the POC. We can call prototype, right? So actually, this image also I generated from the AI tools, right? So see the beauty. So I just tried a script and ask about the design. I have this kind of idea and generate a image about this conceptual idea. Then they will use a Vero.board and generate a image like this, right? But when you go to the mass manufacturing, you have to make a customized PCB. It's okay. Even this is also get from this, right? So I mean, improve to this one. So in industry, we also start with the POC when client asks. So first thing is making POC, proof of concept, right? So it's called prototype, maybe POC, whatever words. It's to share the idea to the client using this type of product, technology proof, right? So then you have awareness about the idea, right? So after that, there are a lot of stages in the industry in the product design life cycle, right? So in this, starting from the POC or prototype, right? So sometimes we can call MVP, minimum viable product, right? So actually to go to the minimum viable product, it's beyond the POC, right? So POC mean actually you can take the device from the market, like Arduino boards or ESP32 boards, and where depend on top of Vero board you can make a circuits, right? But it's okay. But when you go to the MVP, at least you need to have some presentable product, right? So like at least customized PCB, it's good to have a MVP, right? So in the product design life cycle, we start from the POC called prototyping, and after that we go to the EVT, right? Actually, these are testings, right? So in the industry, we do some testing from the concept to the mass manufacturing level, mass production. So we have several stages. See, so I will show some images to get some idea. But these are the stages, right? So this is industrial words actually. POC, EVT, DVT, PVT, right? MP, those are industry terms. So once you test POC, I mean this one, if you verify this one, you can go to the next stage called EVT, right? So that means, so from the market, we can get the boards and the items, and using jumper wires, we can convert the design, right? Prototype, but it is not good to present, right? So next thing is EVT. We have to make a customized PCB to make EVT, electrical verification test, right? So then we know all these items we can integrate together, and you can optimize all these sensors and the things, and we can make a EVT, right? After that, we have to think about the DVT stage. So it's about design verification test, right? So that means we have to think about the enclosures, and if you think about these buttons, UI and UX, right? Even when you design the product like this, imagine foreigners, their fingers actually little bit bigger than us, right? So then it should be a gap in between these two, right? So if it is Asian people, so this distance is maybe less, but for the foreigners, you have to maintain this distance, right? So like a 15 more than the button size also a little bit bigger, and sometimes they need some haptic feedbacks, right? So all this real idea came from the client, right? So you should visualize the end product to the client, right? So then you can test all these things during the DVT, right? So after that, we have to go to the PVT. So then we can make a finalized product, right? So actually, this is the whole journey, but most of the time in the during university, you will end up with this POC or prototyping stage, or sometimes you can go to the EVT, making customized PCB. But in the industry, you have to do a lot of things. Okay, so as I mentioned, first when you get the idea, you have to do a couple of things, right? So you have to do lot of paperwork before starting your project, right? Maybe you have to draw some block diagrams like this, right? So what kind of real pain points they have, and what are the problems and statement and everything, without thinking about too much technical, but all these scenarios you need to get from the client, and you have to think about as you in the field, right? So then only you can get real idea about the problem, right? And also, once you draw these things, you have to, if it is a microcontroller based project, before starting the coding, right? So in the industry also, we write this state machine, right? So in the firmware, so this is actually very useful, and it is very productive and time saving thing, right? Because when you do this state machine, you know every loops and the functions and everything, and even every variable, you know, right? So here you can add every variable, input and output, you can define during this state machine, right? So these are industrial terms, right? So when you go to the industry, you have to draw a state machine before doing firmware, right? So once you draw this state machine, any firmware engineer can do, right? I mean, to design this one, you need to have some architectural knowledge and good idea about its wide knowledge you need to have to design this, right? So then you can define every loops and the functions and everything. Then you can think about the failure things and ideal state and all these status, right? So this is called state machine. You have to do this state machine also before starting firmware, right? And also hardware block diagram, right? So this is also, this is hardware thing, this is firmware thing, right? So also in the, when you design hardware, we have to design block diagrams, right? Maybe when you show this type of block diagram, even you can add not like a blocks, maybe you can add some icons, right? So to get some user friendly feeling. So see, speakers and the buttons, indicators, it makes some real feeling, right? So even when you show this, the management team, even they can understand, right? So likewise, even when you send to the client, if he is not a technical guy, even he can get some idea, right? So this level we have to start, right? But during the university period, actually we don't have a time. Sometimes we try to finish the task during a timeline, no? But when you go to the field, you should do this, right? But if you try to do this way, even when you stop in the middle, you can share the project to someone else in the middle, right? So this is the way how you do the projects in the industry, right? Block diagrams, right? Even when you design this one, you don't need to think about what microcontroller you used. Actually, this is also a little bit advanced one. Actually, you don't need to mention these chips even here. Just it's okay to add some microcontroller, amplifier, and USB hub. Likewise, high level blocks, right? So then later you can do a component selection process later, right? So it is also coming soon. This is called block diagram, right? So now you know you have to start the state machine and the block diagram, right? So if it is a group work, we have to start all these works parallelly, right? So in the industry, so then the project timeline we can save, right? And also we have to think about the if it is a microcontroller based project, you have to maintain separate document like an Excel sheet to maintain all these things, right? So one page you can add the block diagram, second page it's like a pin mapping diagram of the microcontroller, right? So this is very important because when you do the firmware state machine, even sometimes here you can mention like a pin, right? So those pins you can address here, right? So I mean, you can give the same name here. It will repeat every schematic and firmware and everything. You have same name, right? So when you give some names in the schematic, give some user-friendly name, right? So meaningful name, right? For example, when you design something, let me show you. So these are called hierarchical designs, right? So when you address, when you give some name, give a meaningful name like this, right? So then you can understand what is this GPIO defined for, right? So you can give some user-friendly name rather adding like a net names, right? So all are for our easy understanding, right? So also it is very important to maintain this type of document in the spreadsheet. So even when you select the pin mapping, some pins you cannot make as an output pin, right? So because of they have open drain pin. If you try to write a firmware after you design the hardware, you try to write the firmware to make this pin as an output, but you cannot, right? So that is why in the early stage you have to do, or you have to go to the data sheet and find about the pin status and the functions and define all these features in the spreadsheet and maintain these documents, right? So maintaining this document is really useful if it is a teamwork project, right? Pin mapping diagram, right? And next thing is you have to do the power budget, right? So I mean, when you select the component list, right? So components selection also another challenge, right? So you have to select the component list. It should be fit with your budget and everything, right? So also you have to do the power budget, right? So what is important of that is, so I will show you some example. So when you design something like this, right? So there are some internal layers, right? So this is actually a 6-layer PCB, right? So when you design something, so here to here, you need to deliver much current, right? So here to here, you have to deliver, let's say, 1 ampere, right? So how we can calculate those things? So if even in this tool also we can calculate, but there are some open, websites like IEEE Web. If you go to this type of website, they will show how to calculate the trace width according to the current, right? So let's imagine this is a cross section of the PCB and this W is the width of the trace. So let's say if I want to deliver 1 ampere, this width is normally come up with mil or millimeter scale you can select, right? So then we have to select the PCB trace thickness, that means this T. So normally we can call it as a square feet per ounce, right? So then it is normally 1. So then when you input these parameters, you can get the relevant trace width to deliver 1 ampere current, right? See, to deliver 1 ampere current. So this is some temperature coefficient. So then to deliver 1 ampere current, you need at least 12 mil, right? So likewise, that information is very useful when you start to do the layout, right? So then according to that requirement current, you can deliver that current to the relevant module, right? So otherwise, when you do advanced project, maybe 100, your schematic is 100% correct, but when you go to the layout, sometimes imagine if this trace is something like this, you cannot deliver the current, right? Required current, you cannot deliver, right? So there can be a malfunction then, right? So likewise, you have to think everything when you design the circuits, right? Okay, so that is why you need to make this power budget calculation to get some idea. If you are using different voltages, like then for a 5 volts, let's say if you need 300 milliampere, you need to deliver 300 milliampere through that trace, right? So those type of calculation you have to do as an engineers, right? So otherwise you will do a trial and error method. It's not engineering techniques, right? So to be a professional engineer, you have to do this power budget calculation and block diagram and everything to be a perfect engineer, right? So one day in the industry, you have to do these things, right? Okay, so there are 2 methods as I mentioned. One is called waterfall, another one is agile, right? So we have to use in the firmware and hardware, we can use both of these techniques, but to save the risk, the risk, we can use some agile method. We can divide the task into subtask, and then we can finish that subtask like this way in the agile method to save the risk, right? We call sprint, right? So those are some technical terms in the industry, but try to learn those techniques as well, right? Before going to the industry. And also some in the embedded products, it's not enough to deliver the hardware. You have to write about the firmware and maybe the software, right? All these things start together, right? So then your project manager, there should be a project manager in the team. He should track all these timelines and the backup plans and everything. Even now when you are doing the project, for example, even if it is a final year project, maybe you have 3 months, right? But during this 3 months, maybe you have a lot of big dreams and likewise, right? But if you cannot complete the task, you will be failed, right? So it should be a practical timeline with your other works as well, because you cannot work all day, right? So you have to put some hours in during the day to this project. So then it should be practical hours and the timeline and the sometimes component, even if it is a PCB design, it will take 2 weeks to get some PCBs from the China, right? So likewise, you have to at that gaps, during that gaps, you can do rest of the works, right? So likewise, project management is very important when you do the project, right? So at least not only project managers, even as a developers, we need to have that project management skills to manage your project, right? So think about those things as well to complete your project. I will add some tips from the PCB design side as well to get some idea about this product design, right? So these are some technical tips, but it will be useful, right? So as I mentioned before, starting any project, first of all, you need to do a conceptual design like this, right? So the important is when you design something from the scratch. So when you design this product, actually we have to think about, so this is the PCB area, right? So all these wire harnesses we design and we think this way. If we have left side speaker, we have to think about that, right? Also, because when you fit PCB with your product, naturally the left side speaker wire come like this and connect to here, right? It is user-friendly PCB and product, right? So otherwise, if you have a left speaker in here somewhere else, so then you have to use long wire, right? So it is not user-friendly thing, right? So we have to think about UI and UX for this product design as well, even the manufacturing mechanical designs, right? Also in the beginning, so see this. So sometimes we can get the critical component, so right. So this is very small and miniature product. I want to get some idea about this in the beginning of this project. What will be the size, right? So then what I did actually, I just took this Bluetooth module, buttons, and the connector. Most critical part in the project, and I just keep another RC component, but get this high level component put into the PCB, and bottom of this PCB actually we have a batteries, right? See, just make it as a block diagram and get the size, right? So then I know this size, I can make a PCB. That information is really valuable when you design from the conceptual design to detailed design when you move. So this level you can start from the block type of thing, right? So it not should be a very precise thing, but at least rough idea you need to have, right? So likewise, you can start from this type of conceptual design when you start design the mechanical thing as well in the design, right? So also when you deal with different sensors, right? So think about this, right? So in the digital world, we have to deal with the different technologies called CMOS, right? TTL, right? So in the digital world, we can say 0 and 1, but in the real situation is where is the 1 starting and the end point, right? So that means there is a level to trigger it, right? So at least when you say 1, it's goes beyond the 3.3, right? So it's depend on the technology as well, TTL, CMOS, right? So it is very important. So likewise here, 1 is defined about 2, right? So here 1 is defined about 3.5, right? Depend on the technology and the thing, right? And 1 below 0.8, right? So when you deal with the sensors and the microcontrollers, when you communicate, sometimes imagine if it is a ESP32, you have to deal with 5-volt sensor, right? So then your communication, maybe it's work, but it is not perfectly work, right? Sometimes because of this voltage level converters, right? So these type of things you have to think when you deal with the different voltage in your PCB, right? So think about this very carefully, right? Level converters. And also, have you seen this? When you add the buttons, sometimes in the button there are 2 metal surfaces, right? So then when those surfaces will touch, there is a debounce, right? So to mitigate this problem, we can add this capacitor, right? So it's called debouncing capacitor. Before adding the signal into the microcontroller, we can add small capacitor like 1.1 microfarad, right? So then it will smooth and you can get the real signal. Otherwise, if it is a counter or whatever project, sometimes you will get a couple of signals, right? So these type of techniques we can use in the even during software. We can add some debouncing time, but better to solve that problem in the hardware, right? So like this by adding capacity, right? So also when you design low power related stuff, right? So imagine if it is a wristwatch or kind of a thing. So sometimes you have to think different voltage level. Hold on. Right. So now imagine if it is a battery operated device. So imagine your microcontroller is working 3 volt, right? So, but imagine you have battery 6 volt, right? So it will drop down, let's say up to, imagine, right? So up to, let's say 2 volts, right? So when it's discharged, it will go 6 volt to 2 volt discharging, right? But in your system, always you should get the 3 volt, right? So during this one, so 6 to 3 volt, it should be act as a buck, right? But when you discharge beyond the 2 volt, your device, I mean the power side, you should operate it as a buck boost converter, right? So then altogether, this system should have a buck boost converter, right? So that then this device will work up to 6 to 2 volt without having any issues. It will provide always 3 volt, right? So these type of thing you have to address when you do the low power budget design, right? Okay, and these are some layout tips actually. So when you place the component, like this is a capacitor near to the microcontroller, if it is a chip, so you have to place like this, right? So first of all, this trace should come to the component, I mean the capacitor, then the power cycle goes to power line goes to the chip, not like this, right? So if it is a multi-layer one, you can use wire and capacitor is here, right? So then it cannot provide much smooth power lines to the chip because this is away from the line, right? Because current come here and go to here, right? So this is bad way, and use best practices like this, right? Also, you can calculate this type of impedance, right? For example, when you design the USB power line, USB hub, right? So you have to maintain USB data plus line and the minus line. So you have to manage the impedance, right? So if it is a differential pair, right? So you have to manage this distance. Maybe your schematic will be 100% correct, but when you go to the layout part, if you don't match the impedance, your circuit will not work. Like RF circuits, you have to calculate every impedance. If it is RF, you have to maintain 50 ohm impedance. If it is a USB line, you have to maintain the 90 ohm impedance, right? So likewise, you have to maintain, right? So by changing these parameters, you can set the differential pair impedance. If it is a USB line, you have to maintain its 90 ohm impedance, right? By changing this parameter, right? So think about those things, right? And so this is also interesting thing when you place the wires in the PCB, don't place wires on top of the pad, right? What happened then? When you place the wire on top of the pad, when you place in the assembly line, when you add the copper, I mean the solder paste, it will go through this hole, right? So even when you place the paste and solder component, all lead will be go through this hole, right? So please avoid placing wires on top of this pad, right? So like this, at least this is okay, but this is bad thing, right? See, all lead will be go through the hole, right? And also adding ESG chips, right? Because if your device always exposed to the outside, like a USB port in the computer, have you ever feel when you touch the USB port, you will get shocked, right? Why? Because of when you walk, ESD will be charged in the hand, but during um, uh, humidity, it will discharge. If it is not, it is a dry day. That charge will be remain in your hand. When you touch the computer, all ESD charges will go through your hand to the USB port. If you don't have protection, it will go to the chip, right? So better to add this type of chips if you have different ports in your product, right? Otherwise, because of that ESD charge, your product processor will be burned if it is a sensitive device, right? So this ESD is very valuable in the industry as well, right? And these are some techniques also adding stitching wires to remove ESD EMI issues in the PCB. I will explain later. And also when you do some product designing related PCB, you have to add this type of fiducial marks and panelizing and things like that, right? Also, we have to add some test points, right? So to make a jig in the industry, we call jig. So when you make a PCB in the production line, we can place this on top of this jig. It will align with this test point. So these are spring-loaded type pins. So then you can run the test code and you can pass the QA, right? So likewise, there are processes in the industry. And also placing debouncing capacitors, as I mentioned, it should be closer to the chip like this, right? So maintain and placing component is very important, right? So this is also about ESD charge ESD chips. So please add those things into the product, right? So even when you add this type of product into the, when we introduce product into the international market, we have to test a lot of things, right? They are about testing in the in-house. We can test at least when you solder the component, we call that process called bring up, right? PCB bring up, right? So when you get the empty PCBs, we have to first solder the power part, power domain, right? So once you solder the power domain, you have to test, right? So you have to apply some load testing, and using oscilloscope, we can fully loaded the power domain and we can test are there any ripples, noises in the power domain, likewise, right? But nowadays we can order the PCB like a JLC PCB, whatever services, by doing PCB assembly services as well. But if it is a first PCB, I'm recommending to add at least 0 ohm resistors to disconnect from the power line. Then you can test only that region, right? So we can have some that options, right? So by adding some test point, something like this, we can add some test point to separate the power line, something like this, right? So 0 ohm to disconnect this line, then this line is isolated, then we can test the peak. Right? So and after that, we have to do a lot of testing like assembly component and separate functional testing, right? Stress testing, and we can fold it down and we can check the things, vibration testing, right? And everything we have to test, and also EMI testing, right? So EMI mean actually to get this certification, you have to send our PCB into this type of services in the Sri Lanka. I don't know whether in Sri Lanka we have this type of services, but normally we send to the like Taiwan kind of countries to test this thing, right? But it happened actually, it's a concrete kind of a room. We can put our product in the middle and we can apply different type of frequencies, and we can check depend on our different type of frequencies, the product will be fair, or we have to test it in reverse way. When you power up the PCB, it will generate the PCB, it will generate some unwanted frequencies, right? Because if it is let's say in your PCB, so that is why we have to overcome this 90-degree, right? So that means that is why we mostly design the PCB trace like a 45-degree angle like this, right? If it is a 90-degree, this corners will be act as a antenna, right? If it is something 90 ohm thing, so it will act as antenna, right? So that is why we had to overcome those things as well, right? So to mitigate EMI issues, right? So then only we can get this type of certificate when you go to the product design, right? And also sometimes we have to do some burn testing, right? So we have to fully loaded and fully function. We have to run fully functions and we have to check what is the most temperature range of your product, right? Even during the AC machine, and maybe if it is a closed environment, we have to check, right? Otherwise, if it is going to the market, we don't know what will be happen, right? So for example, recently we sent kind of a robot to the US to test, but in that country they have some dry zone, right? Because of that, when robot is walking, it will get some static charge, right? When you touch the robot, we will get the shock, right? So that means when you move that robot, it will get charged, right? So what we did actually, we had some metal strip and make it like a small connection to the ground, and it will discharge, right? So likewise, we have to think all these things. Depend on the environment, most thing will be changed, right? So also we tested the EMI test like this, and are there any unwanted frequencies generated from this? Likewise, we did this type of project. Also, as I mentioned, once you do the project, you have to think about the patent uh, uh, thing about your project, like it's called IP, right? So you have to secure your idea, then you can go to the market, right? So likewise, even in the Sri Lanka, if you have a really great idea, you can apply maybe for a ICT. They have spiralation program. They will fund for you 1.5 million if you have a great idea. And NBQSA award you can apply, right? So it will benchmark your product in the industry, right? So and also SLASCOM, they have a competition called Unity award series, right? So likewise, you can apply those type of thing. And also in Sri Lanka, we have good ecosystem like Trace Expert City and Hatch, right? So likewise, they have good accelerator program, incubator programs. Keep in touch with this program as well, because if you are in the field, try to update with the technology to be a real problem solver, right? So as I mentioned, so this is from one of my product pitching desk. So first of all, you have to identify the problem, right? So when you before solve the thing, first think about what kind of target audience will affect because of your that problem. Then you can address this is my target audience when I build the product, right? So then you can do a marketing for that people, rather apply for every people, right? So think about those things very well. And actually we did a lot of projects like this, and we did a lot of successful projects as well. So these are some automotive projects that we have done for the Malaysian clients, right? So likewise, if you are really capable to solve the problem, you don't want to worry about that, because people will buy your client will be very happy, right? Also, now you have real great ideas when you design your pitch desk, right? So think about different not it should be have even each and every slides don't add too much contents, right? So add some pictures, and first slide like a problem statement, right? So also there should be a slide to add some competitive products, right? So you can add two competitive products like this, and what kind of unique thing in your product you have, right? So in your product, most of features you should have, right? So not like a cross, right? So then your product will be highlighted. Even when you do a presentation, don't tell this is the first product in the world, something like that, right? So that means that represent you are not done this services, I mean studies, right? Because most of product nowadays people already done, right? But there can be unique selling point. You can highlight that one, right? So then you can say there are some unique product, competitive product in the market like this, but these are the unique selling point in my product, right? So likewise, add those things into your product, right? And the business model, how you can market, what is the target audience, right? So we can earn money. Maybe nowadays people are doing subscription based thing, right? And what kind of future implementation, right? So also a team, right? So you should have a divided, diverse team, right? So you can show all these things within a couple of time, right? Maybe 5-10 minutes, sorry, 3 minutes, 5 minutes will be enough to deliver all these things. But try to deliver practice when you do a pitch desk, right? Right. So right. So I think I almost covered the things with the given timeline. And also I would like to tell you, Bruce Lee is a very famous fighter. So he told, so he aware about the people who did the thousands kick, he don't care, right? But if one people practice the same shot 1,000 times, he aware for that. He is more caring about that people, right? Because the thing is, be expert in your subject, right? So whenever you do the things, as I mentioned, do the lot of calculation and everything as engineers, and then only you can be a go-to person in the industry, right? So one day, if you can say, I love my job, something like that, by enjoying with your fashion, if you can solve the problems in the industry, you will win, right? So with that message, I think with the given timeline, I can wrap up this session. If you have any doubts, please feel free to contact me, maybe WhatsApp. I will be help in the future as well, right? So I think you get something from today's session. I think in your product, you will do very interesting projects and solve really good problems in the society, and good luck for that as well, right? So thank you very much for your time, and good night, and thank you very much for inviting me as well, right?
Thank you very much, Mr. Kulathunga. Your words were truly inspiring and offered a wealth of practical insight and wisdom. We are deeply grateful for the time you dedicated to be with us shared. It's clear that your journey and experiences have left a lasting impression on all of us. Once again, thank you very much.
Thank you, Dani and all.
Now, sorry.
No, sorry, I just say thank you. It's okay.
Okay. Now it's time to turn to ask questions. If you have anything you like to ask from Mr. Kulathunga, simply scan the QR code on the screen to access the Slido, or use the link we've just dropped in the chat. Go ahead and ask away. No question is too small or too big. So, Mr. Kulathunga, how do we figure out if an idea is actually worth turning into a product?
We figure out the idea actually working. So that is why I mentioned first of all, you have to do some research in the from the real pain point you have to address first, right? So you should go to the field first, right? So then you will realize that if you have introduced a system, maybe you can do some survey before doing any project. You can go to the field and you can ask, if I develop this type of system, are you going to buy, right? So then if it is your idea, you have to do that type of thing, right? But sometimes if it is a client project, so it will definitely solve the problem, but that problem is coming if that idea generated from your side, right? So then you have to do a survey, go to the market and do a research, right? I think it is clear.
Yes, sir. So, what's the best way to test a solution early on?
Yeah. So in the embedded system, there are a couple of things to test, right? So that means hardware, firmware, and overall testing. I mean, the firmware, software, hardware, everything, right? So we have to categorize the different thing in a different way. Like we can think about the test case, right? So when you, for example, when you want to implement the sensors, so first you can test the sensor. Only that sensor you can write a firmware, you can test it out, and you have a confidence. Now this sensor is working right now, but now when we going to integrate the things to the overall product, then you can have integrated problems, right? So then you have to find about the way how to solve that problem, right? So likewise, testing you have to categorize into different way and think about in agile way, right? So then you can don't think about the overall thing together, make it as a subcategories. Okay. What is the best? Right, it's okay.
The next question is, the tools you used, Altium SolidWorks, are expensive for a university student. Can you please tell how to tackle that problem?
Oh yeah, you can contact with LTM. Actually, they will give some student version for the universities. Recently, some universities also requested. So you can request to the, you can email to them and you can ask about the student version. Then you can get the student version for the university student. And also you can ask from the ACE camp from the SolidWorks. So they will maybe give some student package for you, right? So because their aim is once you learn as a student, when you go to the industry, you will use that software now as a marketing strategy. They will promote the software like that way. Try to contact with them. I'm pretty sure you will get the student versions.
So how do we use the most important features to put into a product?
Most important feature that is depend on your problem actually. So to find about the feature, you have to do a competitive task. You have to make a competitive chart first, right? So then you can compare with other products, because when you have real good idea, uh, already people maybe they have done the product and they introduce that one in the market. But when we introduce same thing into the market, you have a big competition, right? So, but if it is your idea, there can be a unique selling point, right? So this is called unique selling point. So, the question is, how would you choose the most important features to product? So it will align with the first thing that I mentioned. So depend on the client requirement. So do not think about the too much technical thing. Try to find about the real pain points and without adding much more effort, you will realize what features they need. Discuss with the client first and ask about their dream idea, right? So then you can realize the features, what they want. If it is your idea, you can go to the field and ask about the customers about what type of features, facilities you need. Then you can realize what kind of features is the most important thing, right? Okay.
So how to a stress testing, especially on PCB?
Yeah, stress mean actually we have some we can do some vibration testing, right? So that means there are some vibration machines to test physical component damages, or if it is not soldered very well. So we have some machines we can put into that and we can vibrate, and we can later some timeline we can vibrate and we can test it out the PCB. Or stress means sometimes we can run fully loaded program, right? So if it is a microcontroller based one, we can run fully loaded program. That means all sensors we can activate, all peripherals are working, right? So all LEDs and displays and everything is working. That means fully, it will take full power from the batteries. At that moment, your processor will get maximum performance. Then you can measure the temperature and current consumption and everything, right? So those are called fully loaded tests. And also before doing that in real, some simulations are there, like in Altium, they have a PDN analyzer. You can simulate and you can give trace with, let's say, if this trace is 2 ampere, you can simulate it, and if it is not, it will show as a red color. Simulations. Okay.
Sir, in ECEDA, is it possible to make 4-layer PCB? Is it successful? I did not see a direct option, but there was an indirect way it said it was messy.
In ECDA, there is a professional version as well. You can use that version to make it 4-layer PCB. It's all about making a wire and you can manage the layers in between all these things. Use the professional version to make that, right? But when you compare with the Altium, they have limited tools, but using that one also we can do some advanced tool, but up to some extent.
So, what makes our product stand out compared to the other stuff out there in the market?
Yeah, that is I told. So first, the thing is, students when students are doing the projects, they are not finding things in the correct way in the web, right? I mean, using keywords, we have to find about the, maybe if it is a university final year project, maybe 3 days you can spend to find about the competitive products in the market using different keywords, right? So then you can find competitive product. Maybe you can read white papers, right? It's called prior art, right? Prior art search. Sometimes it's really difficult to find about the competitive product by typing in the Google, but when you search papers and the things like that, you can find about unique thing. Some are maybe idea level finished, but some are made like a product, right? So then you can think what features you need and everything, right? And also nowadays you can use AI tools to compare your product. You can ask about the feature list and everything and find about competitive products in the market, and they will show with the product brand names even. Right? So some products are mostly in China market, they have competitive product, right? So the thing is, our browsers, we don't know how to search in the browsers, right? So that is why maybe if you go to the Chinese website, definitely you can find about the market, competitive product. Even sometimes if you don't know to find using keywords, maybe you can upload the images, right? Images into the Google, and you can use a search engine to find out. Right?
That's all, Mr. Kulathunga. Thank you so much. As a gesture of our heartfelt appreciation, we would now like to present a token of appreciation to Mr. Ranjan Kulathunga for his invaluable contribution, insightful sharing, and time dedicated to make today's session a success. Once again, thank you, Mr. Ranjan Kulathunga.
Thank you all.
There is an important announcement to make. The proposal submission deadline is fast approaching. Please make sure to submit your proposals on or before 21st of April. Cash prizes will be awarded to the winner, first runner-up, second runner-up, and the most popular innovation. So make sure to bring your best ideas forward. And now it's time to turn up your energy. Get ready for a Kahoot quiz session, a fun and competitive way to test your knowledge and challenge your fellow participants. Only a limited number of players can join, so hurry up. And please make sure to use your real names as your username so we can identify you correctly. So let the games begin. The link for the quiz is shared on the chat. Just a few more joining in. Get ready. All you have to do is to get the right answer correctly and quickly. There are so many participants. It's getting very competitive. Let's give it a few more seconds. Then we can start. Okay, and here we go. Let the fun begin. What is the main purpose of the block diagram in embedded design? Visualize power traces, estimate cost, represent logical function blocks, show mechanical layout. You have 15 more seconds left. Yeah, I can see answers are coming now. There are 24 answers. Okay, the correct answer is represent logical function blocks. So let's look at the leaderboard. On the top, we have Rusiru. On the second place, we have Vishalya, followed by Dimesh. So let's move on to the next question. Which protocol is the best suited for real-time low-latency communication? SPI, UART, I2C, HTTP. Wow, you guys are answering really fast. You have 5 more seconds left. Okay, the answer is SPI. As you can see, only seven has been able to get the correct answer. So let's move on to the leaderboard. The leaderboard had changed a lot. So in the top, there is Tarindu Dakshi. So in the second place, there is Rashmika N. In the third place, there is Heshan. So let's move on to the next challenge. What is a drawback of using high frequency clock in your design? Lower cost, increased EMI and power consumption, reduced accuracy, slower data transfer. You have 15 more seconds left. The quiz is heating up. Okay, the correct answer is increased EMI power consumption. So many of you have been able to get the correct answer. So let's look at the leaderboard. Oh, Tarindu Dakshi has been able to remain on the top. Also, Rashmika N was able to remain on the second place. There is a new face, Tamalu, in the third position. Oh, Hasindu is the highest climber. So don't worry if you're not on the leaderboard, all of you can get there. So let's move on. One of these tools is suitable for version control in embedded firmware development. Altium, Eagle, Git, Arduino IDE. You have 17 more seconds left. Don't overthink it. Trust your instincts. The answer is Git. As you all can see, many got the question correct, so let's move on to the leaderboard. Wow, big changes on the leaderboard. Heshan has become the first, and Rosiro became the second, and Dimesh became third place. So let's see. Which testing method is performed during development, not after? Functional testing, unit testing, validation, acceptance testing. You have 15 more seconds left. And the answers are rushing in. Okay, the correct answer is unit testing. Let's look at the leaderboard. On the top, we have Rosiru. On the second place, we have Dimesh, followed by Chi, I think. So, Dilukshan is the highest climber on this question. So, let's move on to the next question. Which power supply configuration offers better efficiency? Linear regulator, Zener clamp, series resistor, buck converter. You have 13 more seconds left. I love this energy. Keep it up. So the correct answer is buck converter. As you can see, many got the question correct. So let's check the scoreboard. And once again, holding strong at the top, it's Rosiru. And also Dimesh. Again, Rashmika N has become to the top 3. So, are you all warmed up now? Then let's go. When selecting a microcontroller, what's the most important factor for power-sensitive applications? RAM size, sleep current, number of GPIOs, clock speed. You have 15 more seconds left. Every point counts, so stay sharp. The correct answer is sleep current. So let's check the leaderboard. Looks like we've got a new challenger in the top 3, Dilukshan. But steady on the top. Rosiru, congratulations. And followed by Dimesh. So here comes your next question. What's the typical voltage level of a logic high for 3.3 volt systems? 0 volt, 5 volts, 1.8 volt, 3.3 volt. You have 15 more seconds. The correct answer is 3.3 volt. So we will check out the leaderboard. Still steady on the top, Prosiru. The second place has changed to Dilukshan, and the Tamalu has came the third place. So in this question, Banula is the highest climber. All right, time for the next. Stay focused. In client discovery sessions, which technique helps clarify true needs? Is 5 whys method, showing a demo, competitive analysis, asking for a data sheet. You have 10 more seconds left. The correct answer is 5 whys method. 15 of you have correct answer, so let's move on to the leaderboard. On the top, we have same old Rusiru. Second place has changed. Second place is Mithila, so third place also have changed, which is Sasmita. Okay, Pasi is the highest climber. So let's see. Which component projects a circuit from reverse polarity? Capacitor, PTC fuse, Schottky diode, resistor. You have 17 more seconds left. I can see the answers flying in. Oh, you guys are really fast. The answer is Schottky diode. We'll move on to the leaderboard. Rusiru. Leading the pack right now is Rusiru, followed closely by Mithila, and in the third place we have Tamalu. So let's move on to the next question. Which of the following layout practices reduces EMI in high-speed circuit designs? Place decoupling capacitors near IC power pins, randomized routing, use thinner tracks, increase trace length. You have 10 more seconds left. Be quick, guys. The correct answer is place decoupling capacitors near IC power pins. Most of you got the question right, so let's see. Rusuru. Rusuru is still on the top, and second place has changed, I think. The second place goes to Mithila, and the third place goes to Tamalu. So let's move on to the next question. The last question. Which technique helps visualize all functions and their interactions? Schematic, power budget, BOM, flowchart. 15 more seconds left. The correct answer is flowchart. What a fantastic showdown! It's time to reveal our Kahoot champions. The first place goes to Rusiro. The second place goes to Sasmita, and the third place goes to Mithila. A huge shout to our winners. You truly earned it. You each won a Raspberry Pi Pico as a small token of appreciation from us. And everyone who joined, you were amazing. Thanks for being a part of it and giving it all. So winners, don't forget to take a screenshot of your winning screen as proof. We will share the contact details in the chat box. Please share your screenshot with us. Before we officially end today's session, let's take a group photo. Please turn on your cameras so we can capture this special moment together.
Okay, let's get the photo in 3, 2, 1. Okay, thank you guys.
Once again, a huge thank you to 60 plus participants for your participation. We are really grateful for your incredible energy and enthusiasm. As we wrap things up, I want to say how truly exciting and inspiring this session has been. We believe that it sparked new ideas and motivated you to move it forward in the competition. Remember, innovations start with curiosity and courage. So take that first step, dive in and give it your all. So, wishing you the very best for the rest of FINC 2025. The challenge is yours. The future is waiting. With all that, we conclude this evening's session. Good night, stay curious, and keep innovating. Thank you.